Good morning and welcome to another episode of Geology Hacks with Thomas. Today we're going to talk about and look at lavas, and particular lava called basalt in the area here. It has been raining for about 4 days, which we always welcome here, but now it's time to get out in the sunshine, and this is such a great spot. Let me just explain where we are, and I'll turn the camera around for this. We are here in Hurricane, both is okay, just along the Virgin River Gorge, and we're going to go down in the gorge. You see Zion National Park, little clouds, a little snow on it. You can swing around and see some sandstone mountains, part of the Virgin Anticline. In the back you see a snow-covered Pine Valley Mountain, that's a laccolith. Just walking back, a volcano type of mountain that's called Sullivan Knoll, and that's a cinder cone. As we approach the Virgin River Gorge, we can ask ourselves, why is there volcanism in this area here? This area has undergone quite a bit of changes. For tens of million years this area was compressed. That's the reason we have an anticline here, for instance, as part of the mountain building, which resulted in building the Rocky Mountains, for instance. Then, about 50 million years ago, the tectonics at the west coast changed. Pressure started relaxing. As a result, the mountains which are piled up here started to slide down. That's what started what's called the Basin and Range extension. We swing around, we see some more broad cinder cones. That's two cones, probably aligned along a fissure or crack in the ground. Swinging more, over here we see a series of actually three cinder cones. That's the radio tower cinder cones. Those are the youngest one in the area here in Hurricane. Approaching the gorge here, we see lava flows. There's a nice flow. It looks like there are two flows on top of each other. The lower one is just above the red Navajo sandstone, which is typical for this area here. You can follow the lava flow all the way in the back. Some flow getting lower down. Here we get a nice spaghetti type of flow, and as you swing around we get our basalt, more columns, vertical columns. That happens if the basalt or the lava is deposited on a horizontal surface. The lava cools down, the basalt contracts, makes cracks, and makes this sometimes very beautiful symmetrical columns. If it's spaghetti-like, it just means it probably has been deposited on a slope, indicating that down here for sure the lava totally breached and closed off the valley at one point. We swing around, follow the river here. We are standing on basalt outcroppings here. You can see the basalt here, single pieces here. Nice blackish basalt. Next thing is an oxbow with a flat area down there. Follow the gorge up here and find a way to get down to that flat area. Bottom of the lava flow, resting on the red Navajo sandstone. You see some of the lava flows. This is the one from Sullivan Knoll. Across the river you see more. You've seen them a little before. Just a gorgeous morning. You see the red sandstone underneath the black lava. Nice contrast. Tells exactly the old landscape. We came down from the lava level, basalt level. You still see the basalt columns on the left side. Oxbow, the flat level in the oxbow, and going to cross it down towards west here. This area was inhabited around 700 AD, and you still can find structures here like this walled in, probably a granary here, nicely stones laid on my hiking poles. As a comparison, it's 7 feet long and about 4 feet wide. We are down near the Virgin River on the Oxbow we've seen from above previously. That's basalt outcroppings with some basalt columns there. Again, lava flows. They follow the valleys just like water, so it allows us to look at old landscape forms, and this we can do over here. I just zoom in a little bit more. On top we have the black lava. It's now basalt, some green grown over talus, and below is the Navajo sandstone, and you can follow the line between the two. So this area here is clearly an old valley. Probably it's just an oxbow as well. That shows you the topography. Well, I came up this trail from the oxbow here. Here you see a different type of basalt, roundish rocks encased in a larger round rock. That's what's called pillar basalt. Pillar basalt is the most abundant basalt on Earth's surface, but most is under seawater. If, like here, a lava flow hits water, it forms those pillars as well, in a lake for instance. The molten hot lava doesn't like the cold water, so it tries to produce the smallest surface possible, which is a sphere. As the outside cools down, the basalt cracks because it shrinks. Water can get into those cracks. Steam explosion happened, and a layer of the basalt basically blasted off, and this intrusion of water blasting lasts till the core of pillar basalt is below steam temperatures. And when you get those little basalts, typical for those basalts is also, if you can see here, you have little layers. That's some of the layers left over from the last cracking up of the surface. And this is a nice pillar basalt, roundish. Looks like a nest of eggs. Again, it was not deposited down here, but most likely up here at the horizon, up just at the lower base of those basalt cliffs there. Indicating that yes, at one time this valley was completely blocked off by the lava and a lake formed here, allowing the lava to flow into a lake. Here we're coming to the contact of the basalt with the underlying Navajo sandstone. Plenty of little vesicles here. They're all kind of horizontal. And here you see an interesting structure. Never seen this before. You see this roundish structure? That's a large pillow. And you still can see parts of the cross attached to it on this side here too. So we have pillows in this basalt. So there was water when it came down and solidified, probably just barely touching water here. I hope you enjoyed this little excursion into the Virgin Canyon with its basalt and lava deposits. Red sandstone, blue skies, snow in the back. Lava flows across the valley. Can't beat it. I hope you see you next time. Thank you.